Hello everyone. This is homework number 31, multiplying and dividing rational expressions. So last time we looked at simplifying rational expressions, and we factored their numerators and denominators and either thought about the concept of removing common factors of 1 or, as we explained, cancellation. When we multiply fractions, we basically just multiply their numerators and multiply their denominators and keep them as a fraction. So this is in general a over b times c over d would be a times c, multiplying the numerators, and over b times d, multiplying the denominators. So here's an example where we have 2/3 times 4/5. So we just simply multiply 2 times 4 to get 8 and 3 times 5 to get 15. But if there are common factors between the numerators and denominators, we want to divide the common factors first before we multiply. Or, as we mentioned, removing factors of 1 is another way to think of it. But for example, I don't want to multiply 10 times 27 and 18 times 35. I mean, 10 times 27 is not all that bad. That's 270. But 18 times 35 is really, really large. Especially if there's anything common between these numerators and denominators. So there's two methods you could use. The first method is to write these numbers as products of factors that are common between the numbers in both numerator and denominator. For example, well, there's only one way to write 10, 2 times 5, and I'm going to choose to write 18 as 2 times 9 because 27 can be expressed as 3 times 9. So 9 is a common factor between those two numbers. And then similarly, 35 can be expressed as 5 times 7. So now we can remove the common factors of 1. So the 2's, 2 over 2 makes 1. This 5, let me circle it, over this 5 makes a 1. And then, I don't know, I'm going to put a little triangle thing around this. The 9 and the 9 makes 1. So the only thing that's left over is the 3 and the 7. So the 3 in the numerator and the 7 in the denominator. But the way most people do this, but that's just to illustrate the concept that actually we're going to be using this concept. But the way we typically think about this is if you had 10 over 18 times 27 over 35, you could think about it as follows. 5 is a common factor between 10 and 35. So if you divide 5 into 10, we get 2. And if you divide 5 into 35, we get 7. And then between 18 and 27, 9 divides evenly. 9 goes into 18 2 times, and 9 goes into 27 3 times. But then you could also divide out these 2's. So that 2 cancels to give you 1 with this 2, and we get the same result. So the canceling concept is typically how we go about it, but the idea is that you're really factoring and then removing the common factors of 1. So that's essentially the same thing we're going to do when we multiply rational expressions. Here we have p over q and l over s representing polynomials, and same rule, multiply numerators, multiply denominators. But before we multiply, we want to completely factor both the numerators and denominators, and then divide out the common factors, and then express the result as a product. So in our first example, we can recognize that in the numerator, between those two terms, there's a greatest common factor of 6. So if I factor out a 6 in parentheses, remember we're reversing the distributive property. If you want to show it, you could say 6 times what gives you 6x, and that would be x. Or you could think of division, as we've talked about many times. 6x over 6 is what? But in terms of reversing multiplication, now to get the second term, because remember there's as many terms when you factor out a greatest common factor. There's as many terms in parentheses as there are in the original expression. So the next question to ask would be 6 times what gives positive 6, and that would be a positive 1. Now 5 we'll just have to leave alone. Similarly, the 10 we're going to leave alone. But now the 36x plus 36 has the greatest common factor of 36. So if we factor out the 36, okay, again, reversing the distributive property, 36 times what gives 36x? That would be an x. And then to get the second term, 36 times what gives 36? And that would just be plus 1. So let me rewrite this without all the arrows in there. So I've got 6 times the binomial quantity x plus 1 over 5, and then times 10 over 36 times the binomial quantity x plus 1. And now we can do the cancellations. So the x plus 1's obviously cancel. And this is the type of thing that typically happens. Let's see, the 6 and the 36, you can cancel these any way you want. But 6 goes into 6 once, into 36 6 times. The 5 and the 10, 5 goes into 5 once, 5 goes into 10 twice. And then it looks like I can cancel the 2 and the 6 as well. So let me do it with a different color. 2 goes into 2 once, into 6 3 times. So it looks like the only thing left in the numerator is 1. And in the denominator, oh, just 3. So that worked out really nicely. So all that reduces to 1/3. Okay, so we have to be proficient at factoring. Greatest common factor is the first thing we look for. And in this example, can't do anything with the x, so we'll just recopy it. But with the 2x minus 14, the greatest common factor is 2. So write down 2, open up a set of parentheses, reverse the distributive property. 2 times what is 2x? That's x. 2 times what is negative 14? That'd be negative 7. Okay, so then for the second fraction, the 5 we're just going to recopy. There's nothing to do with that. But the greatest common factor between x squared and 7x is x. So remember the least power. And so if we factor out an x, we can ask x times what is x squared? That would be an x. And then x times what is negative 7x. So we need negative 7. Alright, and let me rewrite that again without the arrows. So x over 2 times the binomial quantity x minus 7 being multiplied by x times the binomial quantity x minus 7 over 5. And now we can do some cancellations before we multiply. And so looks like the x minus 7s are actually the only things that cancel here. So then in the numerator we multiply x times x to get x squared. And in the denominator we multiply 2 times 5 to get 10. Okay, so when factoring, greatest common factor is the first thing we look for. But then don't forget about quadratic trinomials as well as the difference between 2 perfect squares. So in this example, in the numerator, x squared minus 25. So we should be able to recognize that immediately as the difference. And there's two perfect squares, x squared and 25. So product of two binomials, x and x in the first positions, 5 and 5 in the second positions. One's negative and one's positive. And again, it doesn't matter about the order. Similarly, the denominator is a quadratic trinomial. So it's a squared term, linear term, and a constant term. And we know it came from the product of two binomials. And if you want to, maybe instead of cluttering up the work here, I'm just going to go to some scrap paper. If I want to factor x squared minus 3x minus 10, okay, we'd set it up with the x and the x, and then we could use the factor method, only because the leading coefficient is 1. So the factors of negative 10 are 1 and negative 10, negative 1 and 10, 2 and negative 5, negative 2 and 5, and that's it. And so the pair of factors that combine to give us the negative 3 are the 2 and the negative 5. So this would be x plus 2, x minus 5, or vice versa. So a lot of times with some of these problems, you want to use some scrap paper to do the preliminary work. So here we have an x plus 2 and an x minus 5. Okay, now that's being multiplied by x plus 2. That's a binomial. We'll just have to recopy it over x. And now the cancellations. If you want to throw some parentheses around this x plus 2, that's fine. But now we can see that the x minus 5s cancel, as well as the x plus 2s. And so therefore the leftovers, there's x plus 5 in the numerator, and it looks like just an x in the denominator. Okay, so sometimes these problems can get a little bit lengthy. Not that they're difficult, because these are all things we know how to do, but lengthy in terms that instead of one factorization or two factorizations, could have as many as in this example, it's like 4 different factorizations. So set each one of these up. Okay, the first numerator looks like an x and an x. And again, if you want to use scrap paper, that's fine. But this one's kind of easy because you know both signs are positive, right? Because this is constant's positive and this sign's positive. Sign of the linear term, that is. So the signs of the terms in the binomial are both positive. So then I'm just looking for two numbers that multiply to give 8 that add to give 6, and that's a 2 and a 4. So if you want to list the factors, that's fine. And maybe I'll do it for this one. At least I know it's an x and an x. Alright, let me break out some scrap paper and do this. So I'm factoring x squared minus x minus 20. And so I'm going to list the factors of negative 20. And so that would be 1, negative 20, negative 120, no way, 2 and negative 10, negative 2 and 10, those don't work either because we're looking for the negative 1x. So let's see, 3 doesn't divide evenly, 4 does, so 4 and negative 5, negative 4 and 5. And now that's it, and the pair that adds to a negative 1 is the 4 and the negative 5. So therefore x plus 4, x minus 5 is the correct factorization You could double check if you want, calculating the inner product plus 4x and the outer product negative 5x. We get the negative 1x that we're looking for, and it checks. So a lot of this work you might want to do off to the side, but that factors, as we have just shown, as x plus 4 and x minus 5. Okay, for this third factorization, the quadratic trinomial in the numerator, again, an x and an x, the product of two binomials. And I'm just going to kind of use my intuition. See, a 5 and a 3 should work, right? And they're going to be opposite signs, and the larger number should be positive because this 2 is a positive. So go with a positive 5 and a negative 3. That's the correct factorization there. Actually, I'm so sorry. I made a mistake with the earlier one. If we go back, we were looking for, I had recopied this wrong. This polynomial we were looking for, this was x squared plus x minus 20. So we're looking for a positive one, which would be the negative 4 and the positive 5. Okay, so we scratch that out. So it was x minus 4 and x plus 5. That was the correct factorization. So let me fix that here, and again I apologize. So this should have been a minus 4 and a positive 5. Okay, so then we had just finished that one, and now the last one. Okay, this one I think we could do because all signs are positive. If you want to write the factors, that's fine, but hopefully you become proficient enough that, okay, we need two numbers that multiply to give 16 that add to give 8. Well, it's not 1 and 16, it's not 2 and 8, looks like it's 4 and 4, and both are positive. Okay, so now the cancellations. So anything in the numerator with anything in the denominator. So checking term by term, this x plus 4 can go away with one of these. This x plus 5 can go away with this one. And it looks like that's it. So in terms of our final answer, we want to leave it as x plus 2 in parentheses times x minus 3 in parentheses over the x minus 4 and x plus 4, both respectively in parentheses, because that's what we consider to be factored form. Okay, so we don't want to multiply that out. Okay, so then the next page, just more factorizations, but now the concept of division. And with division, there's just simply one extra step, because division means multiplying by the reciprocal. So, for example, the definition of division, this is for rational expressions as well as real numbers, but you have P over Q, R over S. So P over Q divided by R over S is P over Q times S over R. So some people say keep change and flip. In the old days we just used to say invert and multiply. But a lot of people use that terminology, keep, change, and flip now. Alright, so the procedure, if you need one, change the division to multiplication. So that's immediately. Immediately want to change it. Okay. And so you don't even think of anything else. And then it's the same process as before, as multiplication. Factor, divide out the common factors, and express your result as a product. Okay, so for number 1, in the numerator of the first term, there's a common factor of 5. Oops, I'm sorry. I'm jumping the gun here. Because what did I just tell you? I just told you the first thing you do is you change division to multiplication. So you just simply recopy, in this case 5x minus 10 over 12, change that to multiplication, and take the reciprocal of the divisor. So you just flip it over, 8 over 4x minus 8. Alright, now the factorizations. Alright, so in the numerator, greatest common factor is 5. So we factor out of 5. Reversing the distributive property, 5 times what's 5x, that's x. 5 times what is negative 10, that'd be negative 2. And that's all over 12. Just have to leave that as it is, and then times, need to recopy the 8. And then for 4x minus 8, greatest common factor is 4. And if we factor that out, 4 times what is 4x, that's just x. And 4 times what is negative 8, that'd be negative 2. Alright, and let me remove the clutter of the arrows. Hopefully at this point you don't even need those arrows and you can just do the factorization mentally, but if they help, by all means use them. So I just recopied everything. And now cancellation. So now the fun part, right? Alright, and you can cancel up and down, side to side, as long as it's numerator and denominator. Cancel in a variety of ways. Like maybe you'll notice this 4 divides into 8 2 times. So 4 goes into 4 once, 4 goes into 8 twice. But then the 2 and the 12 can be reduced. 2 goes into 2 once, into 12 6 times. I can't do anything with the 5, but the x minus 2's cancel. And so it looks like the only thing that we're left with in the numerator is a 5. And that's over in the denominator. The only thing we're left with is a 6. Okay, so it's pretty much the same as multiplication, just the one extra step first. And that is to rewrite the first term, so 7 over 6p squared plus q. Change to multiplication, take the reciprocal of the second fraction. So 18p squared plus 3q over 14. And then this particular one, it's got the 2 variables, the p and the q. And we'll have to just recopy the 7. And actually there's nothing in common between the 6p squared plus the q, so we'll just have to rewrite that as well. And it looks like the only thing we can do from the numerator is factor out common factor of 3. Alright, I'm not going to use the arrows here. We'll just reverse the... Alright, I'm going to. 3 times what is 18p squared? That'd be 6p squared. And then 3 times what is 3q? That would be plus 1q, or just simply plus q. Then we recopy the 14. And then let me recopy everything without the arrows. So the 7 over the 6p squared plus q. 3 times the 6p squared plus q is a binomial over 14. And now we cancel. So if you want to throw some parentheses around this 6p squared plus q, those will cancel. One's in the numerator, 7 and 14 cancel. 7 goes into 7 once, into 14 twice. And it looks like the only thing that's left in the numerator is a 3. And the only thing that's left in the denominator is a 2. Okay, so a couple more, and again, there's just more factorizations, right? So, but the first thing we have to do might seem almost like busy work, but you've got to do it. Just make sure you recopy everything correctly here. So a squared, first one's recopied as it is, a squared plus 7a plus 12 over a squared plus 5a plus 6, and then times, again, change the division to multiplication. Now we have a squared plus 5a plus 4 flipped over, so the reciprocal of this fraction, over a squared plus 8a plus 15. Okay, now I think all of these are actually kind of easy because all the signs are positive, right? So without having to go to scrap paper, but if you need scrap paper, that's fine. But without having to go to it, because all signs are positive, a and a, plus and plus, two numbers that multiply to give 12, that add to 7, 3 and 4, 4 and 3, it doesn't matter what order. This denominator again, a and a, plus and plus, multiply to give you 6, that add to give you 5, it's going to be a 3 and a 2, so plus 2 plus 3, or vice versa, doesn't matter. And again, if you have to go to scrap paper, that's fine. Okay, for this numerator of the second fraction, again, a and an a, plus and a plus. Looks like two numbers that multiply to give us 4, that add to give us 5 would be a 1 and a 4. And then in the denominator, same idea. A and an a. And two numbers that both positive, that is. And two numbers that multiply to give us 15, that add to give us 8, would be a 3 and a 5. Okay, so we typically see cancellations, and there's not much going on here. The only things that actually cancel are this a plus 3 with this a plus 3, or you could cancel the other a plus 3s. Everything else actually stays, so that's just the way it happened. So we actually have something a little cumbersome looking here. A plus 4, a plus 1, another a plus 4 over a plus 2, a plus 3, and a plus 5. Okay, so as long as we're confident in our factorizations, that's pretty much all we can do. Alright, so then our final example, in the first fraction, we have things that we're just going to have to leave. X plus 2 over 7 minus x. The second fraction, quadratic trinomials. So in the numerator, an x and an x. Okay, if you want to use some scrap paper to do this, x squared minus 5x plus 6. We're going for factors of positive 6. It'd be negative 1, negative 6, 1 and 6, negative 2, negative 3, 2 and 3. And the pair that combines to give negative 5 is negative 2, negative 3. So, setting up the factorization again, the x and the x, and we just discerned a negative 2 and a negative 3. I'm sorry, I made a mistake. before I do that factorization, the factorization's fine. But before I do that factorization, I had to change to the reciprocal. So, we got x squared minus 9x plus 14 over x squared minus 5x plus 6. So I apologize for that. Alright, so now we do the factorization. Okay, so again, the first thing you should do, I got a little excited and wanted to jump in and factor right away. But the first thing we should do, so we don't forget to do it in the future, is change multiplication and the reciprocal. Alright, so now we're good. Okay, we had just factored this denominator, right? So let's put that in there. That was the x minus 2 and the x minus 3. Alright, and how about this numerator? It looks like an x and an x, and if you want to use some scrap paper to factor x squared minus 9x plus 14. Factors of positive 14, 1 and 14, negative 1, negative 14, 2 and 7, negative 2, negative 7, and that's it. And the pair that combines to give negative 9 is the negative 2 and the negative 7. Oops, sorry. Give you a second to catch up there. I was hiding it from you. So negative 2 and negative 7. So with regards to the factorization, again, two binomials, x and x, minus 2 and minus 7. You can perform the check if you want as well. So it's an x minus 2 and x minus 7. Okay, so here's an interesting one, because we can certainly cancel these x minus 2's. But now, if you recall, x minus 7 and 7 minus x are what we call opposites. So we cancel one of them. If you wanted to put this 7 minus x in parentheses, that's fine. Same with this x plus 2, you can put that in parentheses as well. But recognizing 7 minus x and x minus 7 as opposites, remember, we cancel one factor, replace it by a 1, and that's typically going to be the factor in the denominator, and then cancel the factor in the numerator and replace it by. And that's all the cancellations. So when we write this fraction, we should have the negative 1 out in front of, and then you have to put parentheses around that binomial x plus 2 over. Parentheses really aren't necessary because x minus 3 in the denominator is the only factor. Or, that's the way I would write it, but if you wanted to, you could put the negative right out in front of the fraction bar. But I think you're safer writing it as we have here. Okay, but this would be equivalent as well. Alright, so that's the end of homework 31. So we'll come back when you're ready for homework 32.